Hello, learners. I'm Anthony. Welcome to today's lesson. I'm the founder of sigmasandtutors. But before we continue, I'd like to remind you to press the red subscribe button right below the video that you're watching right now, and the bell-shaped button next to it. It's free of charge, and it's a convenient way to ensure you are notified about our videos as soon as they are uploaded, and you have the opportunity to do that right now. For our first trick question today, I want you to tell me what pattern that is. So I want you to tell me the name of the pattern, the person credited with discovering it, the next number in the sequence after the 8, and as well as how we find the next number. And you can stick around till the end of the video where I'll reveal the answer. Right, so today's video really should have been our first for our number patterns topic, because you have to understand the language to be able to communicate, right? Now, I don't know why I didn't think of that in the beginning, but I guess all the credit goes to my learners, because, I picked up that most of their troubles in this topic emanate from a direct lack of understanding of the language. But we're here now, and I'll make sure to put this video right at the top of the playlist to create a nice package for you guys. And let's get right into our topic for today. Now let's start by defining what a number pattern is. So this is an array or sequence of numbers that follow a particular pattern. It's really hard to explain what a number pattern is without actually using the word pattern, because it's such a common term. But I think you guys know what a number pattern is. For example, the numbers 3, 6, 9 follow a pattern because we add 3 every time. Another example is 3, 5, 9, 14. Here you'll notice that we add the even numbers 2, 4, and 6, which also follow a pattern where we add 2 every time. So these are not just randomly arranged numbers. Hence we talk of progression or pattern or sequence. By the way, progression, pattern, and sequence mean the exact same thing in math, or at least in this particular instance. So they may be used interchangeably. Another important concept in this topic is that of the nth term. A lot of you guys have a problem with this one, but this is simply the formula. So if you're asked to determine the nth term, you know they're looking for the general formula. For example, Tn is equal to 3n plus 5, an example of an arithmetic formula. Or Tn is equal to 2n squared plus n plus 7. That's an example of a quadratic formula. And so on. And then another important thing is, when we're describing the progression, we mostly use the operation signs of increase, like plus and multiply, and avoid those of decrease, like minus and divide. What do I mean by that? Let's say you're given the progression, that right there. You'll notice that here we divide by 3 every time. But instead of saying that we divide by 3, we rather say you multiply by a 1 over 3. Now you'll remember that, that when you switch between divide and times, you use the concept of a reciprocal. So instead of saying we divide by a 3, we rather say you multiply by the reciprocal of 3, which is 1 over 3. That right there, right? But because, if you say that we divide by 3, it's easy to think that the common ratio there is 3, which would be misleading, because another person may interpret that to mean that, the common ratio is 3, which in fact would be incorrect, but it's instead 1 over 3. So, now if you don't understand what a common ratio is, you can stick around towards the end of the video. I'll explain that to you guys later. Okay. Now, we apply the same rule in arithmetic progressions where, given, for example, the pattern 21, 18, 15, and 12, and we subtract a 3 every time, because 21 minus 18 is 3, 18 minus 15 is 3, and so on. instead of saying that we subtracted, instead of saying that we subtracted 3, we rather say we add a negative 3, right? For the exact same reason that I just explained to you, using the example of the geometric pattern. Now, another similarity between the arithmetic and geometric sequences are the constants and coefficients. For example, A always refers to our first term for both types of sequence. C always refers to the constant for all 3 types of sequence. So C, whenever you see a C, it always refers to the last term. Like in that example, 7 and 5 would be our constants, would be our numbers. All right. And B usually refers to the middle term in our quadratic formula, like in that example. So B in that case would be 1. The value of B in that case would be 1. But because it's a 1, we don't have to write the 1, because you don't say that you have one cellular phone. You rather say you have a phone. So we just write an N instead of saying 1N, right? And another concept of, okay, we already discussed the concept of a sequence. It means the exact same thing as progression or pattern. And a series is, it's really the sum of the elements of a sequence, like in that example. And it's usually, the elements are usually separated by plus instead of the semicolon.